Namaste everyone. In this video, we shall solve a problem related to physics. It is from electricity chapter. This is a competency focused practice questions. I've already made a video on competency focused practice questions and how to download CFPQ, that is competency focused practice questions, from the CBSE website. You will find a video related to this in my YouTube channel Vinayaka AV. Please look into it as well. Before we solve this problem, I have a request. I request you to contact this number 9742774659 through phone call or WhatsApp for online tuitions for individuals or in groups. Subjects: math, physics and chemistry, classes 9th, 10th, 11th and 12th, including PUC, that is state syllabus. Now let's get back to the problem. Here there are three resistors which are connected in this way. They are attached as shown here. He says the resistance of F and G are 10 ohms and 5 ohms respectively. It means that the resistance of resistor F is 10 ohms and the resistance of the resistor G is 5 ohms. The resistance of this resistor E is unknown to us. It is, therefore I am not writing, it is not given to us. These resistors are connected to a battery whose potential difference is 6 volts. Now the first question is, what is the term used to describe such an arrangement of resistors? You can easily see that these three resistors are connected in parallel. So what is the term used to describe such an arrangement of resistors? The term that is used to describe this arrangement of resistors is parallel arrangement of resistors, or the resistors parallel arrangement of resistors, or the resistors are in parallel. Now let's answer question B. What is the resistance of E if 0.3 amperes flows through it? Now let's take the current that is drawn by the three resistors from the battery as I. This current I flows up to this point. At this node or junction, the current will divide itself. Let's assume the current through this resistor E is I1, current through resistor F is I2, current through resistor G is I3. At this point, the same three currents I1, I2, I3, they will merge or they will add up to form the current I. Now he says the current through it means the resistor E is 0.3 amperes. That means the current through the resistor E is I1 and its value is given as 0.3 amperes. So I1 is 0.3 amperes. Now whenever two or more resistors are connected in parallel, the potential difference across each resistor will be same. Here the potential difference across the three given resistors will be equal to 6 volts. So I'll write V is equal to 6 volts. V is the potential difference of the battery. It is the potential difference across the resistor E, F and G as well. Now we need to find out what is the resistance of this resistor E. How are the three quantities V, I and R related? We can relate these three quantities V, I and R by the mathematical form of Ohm's law, which is V is equal to IR. This is nothing but Ohm's law. Now here let's take the current as I1 because we are finding the resistance of the resistor E. I will label the resistance of the resistor E as R1 or RE. Let me label it as R1. Now V value is 6 volts, I1 value is 0.3 amperes into R1. So R1 will be equal to 6 divided by 0.3. So from this, if you multiply the numerator and the denominator by 10, it will become 60 by 3. So this will give us 20 ohms. So what is the resistance of E? Resistance of the resistor E is 20 ohms. 20 ohms. Now what is the total current flowing through the circuit? Here total current flowing through the circuit I have represented by the letter E. We need to find out what is the value of I, the total current. Now I already told these three currents I1, I2 and I3 at this node will join or will add up to form I. So I will be equal to I1 plus I2 plus I3. We already know the value of I1, which is 0.3 amperes. We need to find the values of I2 and I3. Then if you add all these three, we'll be getting the value of I. So let's do that now. So again, I1 is the value of I1 is given as 0.3 amperes. Here you can see 0.3 amperes. I2 is what we need to find out. Again, V is equal to I2 R2. V is equal to I2 R2. Actually, this is from Ohm's law. V is equal to IR. Now, what is I2? I2 is the current to the resistor F, and R2 is the resistance of the resistor F. So now V, as I told before, the potential difference across the three resistors will be equal, and it will be equal to the potential difference of the battery here. So what happens now? V value is 6. I2 we do not know, that's what we need to find out. R2 is nothing but 10 ohms. So I'll write 10 ohms here. So the value of I2 will be 6 divided by 10. So I2 will be equal to 0.6 amperes. This is the value of I2. Now similarly we need to find the value of I3. Again, using the formula V is equal to IR. Now the current is I3 through the resistor G. I will assume the resistance of the resistor G as R3. V, it will be equal to 6 volts. I3 we do not know. R3 is given as 5 ohms. So I3 will be equal to 6 by 5. So I3 will be equal to 1.2 amperes. 1.2 amperes. Now we can say from the figure it is quite evident. What is quite evident? The current I will be the sum of these three currents. These three currents I1, I2 and I3 will merge or will add up to form I. So I is equal to I1 plus I2 plus I3. So as you know, I is the total current and we need to find out its value. I1 value is 0.3 amperes. I2 value is 0.6 amperes. I3 value is 1.2 amperes. So if you add up 0.3 plus 0.6 is 0.9, 0.9 plus 1.2 is 2.1 amperes. So what is the value of I is 2.1 amperes, and what does it represent? It represents the total current flowing in the circuit. So the total current flowing in the circuit is 2.1 amperes. So we have answered all the three sub questions of the given question. Thank you for watching. Please subscribe, like and share. Please share this video so that those students who do not have the facilities or the accessibility or access to good teaching shall find these videos. They can use these videos for free and learn the concepts better. Thank you again. Please subscribe, like and share. Thank you again.